Hello there, and welcome to Spatial Spotlights. These are our weekly webinars that we do with Carto, little 15-minute webinars to give you a little taste of the types of location intelligence that you can perform with the Carto platform. My name is Helen McKenzie, and I am really excited to be with you today talking all about wind turbines. I am just going to check that you can hear me in the chat. There's actually a 2-minute lag between the platform that I am presenting on and the platform that you're watching me on. So if there is a problem, I will fix it in 2 minutes, but I believe we are okay. So I'm just going to crack on. So as I said today, the problem that we're going to be looking at is the placement of wind turbines and site selection for wind turbines. This is a really, really interesting problem because it's quite a contradictory one. When you're placing wind turbines, you often want them to be in a really remote location, but not too remote. You still want to be around infrastructure, you still want to be around people so you can actually get that energy to them, but often people don't want to be around wind turbines. So it's a really interesting problem that we're going to be looking at today. I also think if you're new to spatial analysis and spatial data, this is a really interesting use case to sort of cut your teeth on. That might be a really English phrase, basically try out location intelligence with, because there's so many different types of data and so many really fundamental spatial concepts that you will be working with in this type of use case. So I really recommend having a go at something like this. I will put a link in the comments to a tutorial we have that covers all of this, so you can have a go yourself. So without further ado, let's get going. I'm just going to share my screen, which hopefully you can see now. We are going to be looking at deciding where we think we should put a wind turbine in the states of West Virginia and Virginia in the USA. And there's a few different data sets that we're going to be using to make this decision, and I'm just going to run through these now. So before I get started, I should just say that all of these data sets are completely open, completely free. Anyone doing location intelligence can access this data, and I will include a link to the different sources in the comments of this afterwards if you want to have a play around yourself. So the data sets we're going to be looking at are, first of all, high voltage power cables. So obviously, if you are building wind turbines, you will save a lot of money if you can build them close to existing high voltage power cables, so you don't have to build your own as well, basically. So that's the black lines that you can see here, high voltage power cables. Next, major highways. So when you are constructing your wind turbines and also when you're maintaining them, it's really important to be close to the major transport networks so you can access that and get all your materials to and from your construction site. So that's what we have here. The blue lines are our major highways. So already we can see that we're going to be wanting to put our wind turbines in a location that's close to both of these features. However, there's also things that we want to avoid, such as protected land. So these purple areas here are things like nature reserves and reservations and basically environmental or demographic designations that we wouldn't be able to build a wind turbine on. So that's these protected lands here. So those are ones we're going to want to avoid. But also, as well as wanting to avoid these purple areas but be close to the power cables and major highways, there's a couple of other factors we want to consider. So next is wind speed. So obviously with wind turbines, the higher the wind, the stronger the wind, the more power you're going to be generate, the more return on your investment you're going to be seeing. So we ideally want to have a wind turbine in one of these dark blue areas here where the wind is highest. And then also, I'm in the UK, and NIMBYism, not in my backyardism, is a really big thing here, where people are really pro-green renewable energy, but they don't want to live really close to it, and they don't want to see it when they look out of their window. So we also want to be putting our wind turbines far away from areas of high population, and that's what you can see here. So these dark purple areas are areas of high population. So those are the sort of 5 things we're going to be looking at today. Obviously, if you are doing this sort of for real and you're actually deciding where to place your wind turbine, there's going to be a lot more factors that you would want to look at when making this decision. This is purely a 15-minute webinar to illustrate these sorts of concepts. So yeah, it's quite a simple look, but it's covering a lot of the ground. So I'm going to quickly show you how we might start to look at this. So I'm just going to move into Carto workflows. So if you aren't a Carto user, and if you're not, I'll just give a quick plug now. You can head over to carto.com and grab a free 2-week trial and try out any of this for yourself. But if you aren't familiar with this tool, this is Carto Workflows. So this is our low-code interface for doing iterative drag and drop analysis. sort of building these pipelines that are quite complex, but without having to use much code at all. So they're really, really helpful for people like me who can code but are quite bad at coding. So I definitely recommend giving this a go. So I've already run this just for speed because I've only got a short session with you today, and I'm just going to talk through what this process looks like. So first of all, in the top left of my screen here, we have our something called spatial features, which is basically a data set that covers the entire world, but here it's just looking at Virginia and West Virginia, and it includes data set on demographics, the environment, the economy, all sorts of things. At the moment, if I just expand down here, we can preview our data. You can see that we've just got our index ID, so this is the spatial indexes. I'll just show you actually. Are basically global grid systems. This one is called H3, which is a hexagonal grid system. Next week, my colleague Aaron is going to be doing a webinar all about H3, so I recommend coming along to that if you want to learn more about it. But you can see we've got a sort of grid of hexagons covering our study area here. And then the data behind that, we can preview that as well. You can see we've just got the average wind speeds, which we'll be coming back to in a little bit. At the moment, we're just caring about the actual grid itself. So the first thing we're going to do in this workflow is convert our spatial indexes to a geometry. So if I just come back to our spatial indexes data, you can see that each of these have an ID. What's really interesting about spatial indexes is they are placed in the world by a sort of short ID. You can see here it's about 14 characters. That's how they're geolocated on the world, which makes them really, really small to store as opposed to a traditional geometry. But it does mean that in some circumstances, you have to convert them to a geometry to be able to do some sorts of spatial analysis. So that's what we're doing here with the H3 center cell here. So that's converting each of our H3 hexagons into a point. And you can see we've got this geometry field here. And I can just preview that in this map. And you can see there's our 237,000 points that we're going to use for the rest of our analysis. So first of all, we're going to say we're only interested in cells that are within 15 miles of those power lines that we looked at earlier and within 15 miles of those highways. So what we're going to do, you can see we've loaded both of these in here. And you can see on the left actually here, we've got this panel called sources, and you can drag and drop all of your data sources that you've got stored in your data warehouse onto this screen and use them as part of your workflow, which is exactly what I've done here. So first of all, I run 15-mile buffers on each of these data sets. So let's just take a preview of one of them. And you can see here we've got 15-mile buffers around each of our power lines and each of our highways. So the first thing we're going to do is run a spatial filter. And this will show us, first of all, here we're doing this with our H3 index and our power line buffer. So the results that you can preview here, these are all of the cells that fall within 15 miles of the power line. Secondly, we're doing that again. And on the results of that data set, we're then going to say, and from those, we're then only interested in the cells that are within 15 miles of the highway. And you can see we're starting to cut this down. But you can see when you're running workflows, you can see that you get a preview of the number of features each step is generating. You can see this step has generated 27,500,000 about cells, which is actually more than the input H3 index was. The reason for this is because if I just go back to the buffer here, a lot of the buffers are overlapping. And when they overlap and multiple H3 cells overlap with multiple buffers, duplicates are generated. So we're just going to do a quick group by here. And this basically gets rid of all of the duplicates. You can also use group by to do some really nifty things with sort of averaging. If we had numeric variables in here, for example, if I had wind data or population data, I could use this to summarize the variables within each H3 cell. But I'm purely interested in where the H3 cells are. So you can see I've run a group by, and now we've limited our data set down to 150,000 H3 cells. So these are the areas that are within 15 miles of our power lines and 15 miles of our highways. The next thing we want to do is work out which of these intersect with a protected area, so a nature reserve or a reservation or something like that. So we're going to run a spatial filter again on our protected areas. So you can see this is much lower now. The number of H3 cells that intersect with those protected areas is much, much lower. And you can see them here. There's about 9,000 of those, 10,000, sorry. And then the final step here is we're going to bring all of this together. So I'm using a custom SQL select here. So I did say at the start of this that workflows is low code. In many instances and many use cases, completely no code. But there are still some cases, especially because this is still quite a new tool, but there are still some instances where you might be wanting to use a little bit of SQL, and this is one of them. So this SQL is basically saying, hopefully you can see this and my screen isn't too small, maybe I can zoom in a little. We're basically saying you can call different components without having to type out the whole name. You can see I've called here $A, $B, $C. So you can use that to call different components in a custom SQL select. So we're basically saying I want to select all of the spatial features from our original input where the index is found within the 15-mile buffers, but it's not found within the protected areas. And then the results of that, you can see in the map here. Let me expand that. The results of that are here. So these are all the cells that within West Virginia and Virginia that could feasibly be the locations for a wind farm. They're close to the transport infrastructure, they're close to the energy infrastructure, but they're not intersecting any protected areas. So let's just take a quick look at those on a map. I think I had it loaded up on here, hopefully. Fantastic. So these are all of those areas that we're potentially looking at. So the next thing we want to do is rank all of these areas based on how suitable they would be for a wind farm, how good they would be, basically. So there's two factors we're going to look at in this. One of them you can see I've already loaded up on the screen here. So this is looking at the total population who live within 20 kilometers of each cell. So if I zoom into here and I click on one of these cells, you can see a number that I really should have made to look prettier before doing this demonstration. But you can see within this cell, for example, you've got 944,000 people living within 30 kilometers of this cell. So it's not looking at the in situ population. The in situ population is going to be much smaller. We can see that again here. But we're looking at the number of people living within 30 kilometers who could potentially be affected, whether that's visually or by noise or whatever, by these wind turbines. So we're interested in those. And then we are also interested in the wind speed. So ideally, the best place for a wind farm would be where the wind speed is really, really high, the population is really, really low, and we fall within one of these areas. So for the final 3 minutes of this, hopefully I can do this in 3 minutes, I will talk through how we will get to that. So I'm going to head back to Carto workflows, and I've got two data sets loaded in here already. They're the same, they cover the same area, they're the same grid that we just generated in the previous step, but one of them has a population within 30 kilometer variable that you can see here, and one of them has an average wind speed that you can see here. The reason they're null is they are in the sea, and that's not covered by this data set. So the first thing we're going to do is normalize these data sets. So you can see in workflows, I think I breezed past this earlier. That wasn't meant to be a pun. I hate that I just said that. There's two sort of elements to this panel in workflows. So first of all, there's sources where you can drag and drop your data sets that you have, but there's also components, and this is where you can access your analytical functions, your data processing functions. The one we're going to use here is Normalize. So Normalize, let me just get these running because they can take a little while, and then I'll talk through what they do. Average wind population, perfect. Normalize basically takes all of the numbers that you have in a variable. So for instance, all of our average wind speed, and scores them from 1 to 0, 1 being the highest wind speed, and 0 being the lowest wind speed. So it's really, really helpful to do this for loads and loads of cases in spatial data science. In this case, it's really helpful because it means that we can combine the two different variables into one score and help us say, this is the one place where we should be building our wind farms. So now you can see we have normalized our data. So let's just take a look in the data table so you can see what it looks like. So yeah, you can see here we now have scores ranging from 0 to 1 on the population. So now we just need to join the two of those together. So I'll find a join component. And you can see there's different types of joins available depending on what it is that you are trying to do. And we'll select the join column, so the common column in each of the tables. It's already guessed that the one I want to use is H3, which is great. So I'll just quickly run that. And with workflows, you can run them you can build the whole thing and run it all at once, or you can run it step by step as I'm doing here. I sort of tend to do a middle ground. I like to do it step by step and check things are working. But sometimes if I'm really confident, I'll just go for it if I've done it before. So great, those two are joined together in one table now. As you can see, we've got our two normalized scores here. So now all we want to do is add the two together. So we will now have, instead of having two scores from 1 to 0, we will have one score from 2 to 0. So 2 being, this is the best place for our wind farm. This fulfills all of our criteria. And 0 being, this is the worst place. It fulfills none of our criteria, to put it very bluntly. So now we just want to create a column that will be our final index. So let's call that index, and we just need to add the 2 together. And this is where my spelling will let me down. I think I just need to rerun that because I think I've just managed to cancel the workflow. Apologies on that. Always do something like this when you're doing a live demo. Great. So now I just need to find my 2 normalized columns. So we want average wind norm. Sorry about this. I've got a new computer today, and I'm learning that on a Mac you don't do Control-C to copy things, and it's taking me a lot slower to do things, but hopefully that means that you're getting to see this in action loads of times, so the message is really going in. So what we need here is we want to sum our population index, normalized index, with our wind index. So population. And what I'm also going to do is I'm going to invert the index for the population. So you can see I've just done 1 minus, and that's because we want the index to be reversed because we want the lowest population rather than the highest population. So let me just join that, and let's run that again. And this should give us the index that we want, that will tell us where our optimum wind farms locations are. Except I did a typo. Always. Average wind norm, not wind average norm. Such a classic mistake. Just run that again. So you can see it's really helpful having all of these error messages that come up when you do something wrong. They happen for every step. If something goes wrong, it also generates the number of features that you've created in each step. So you can really quickly say, hang on, that doesn't look right. I think something's gone wrong there. It's not a sort of black box of analysis. Okay, great. So that has run. So now we should have, when this is optimized, you can see, great. So we've now got our final output. So we've got a data set with a column called index here. You can see some of them are null, and that's because, again, they're in the C. But we have our scores from 2 to 0 saying how optimum these are for wind farms. So we can now quickly I'm over time. I'll show you this super quickly. Really quickly create a map and look at the results. So you can see you can preview it on a map in here, or you can just click create map and it will generate a builder map for you. And here are our results. So what I'm just going to do is style this up really quickly so we can take a look at where the best areas are for a wind farm. So we want to style this by index. I'll just change that to average. Let's just change this to an easier color to see. Change the color scale to quantile. Let's just turn that up. So these dark blue areas, let me just change the base map so you can see what's happening here. These darker blue areas, or dark green, depending on how you recognize these colors, I feel like I always see them differently to other people, are the areas that would be best for our wind farms. So they are close to our energy cables, they're close to our transport infrastructure, they're not they're not intersecting any protected land, they have a high wind speed, and they're also far from a large urban area. So there you go. That is a really quick workflow of how you can use all these different types of data and all these different spatial analytical functions to really quickly work out some areas that might be optimum for wind turbines. This workflow was looking at wind turbines, but really these kind of concepts you can use to apply to anything really. So maybe you're trying to work out where you want to put your new mobile phone tower. You might want to use some of these concepts as well. So you might want to be sort of close to population, but not too close. You might want to be close to transport infrastructure. So this is being focused on wind farms, but there's so many more applications to this than just that. So that is pretty much everything from me. Thank you so much for coming along to this. Thank you so much for bearing with me as I navigate my journey from a computer to a Mac. I'm slowly getting there. As I said at the start of this, we do one of these every week at the same time. So next week, my colleague Aaron Frame will be talking all about H3 spatial indexes, which you saw a little bit of today, but he's going to go into that in much more detail. So I definitely recommend you come along to that. And I think that's everything for me. Thank you so much for coming again, and have a great rest of your day. Bye.